Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco's DevNet organization, and today I'd like to talk to you about APIs. They're everywhere, but what are they? This is a part of our Network Programmability Basics video course, and it's in our Programming Fundamentals module. In this module, we've already talked about data formats and gone through JSON, XML, and YAML. And now we're going to go into APIs, how we connect together software and systems. Following this lesson, we'll dive into REST APIs more, and then talk about Python as a scripting and programming language that you can use as a foundation for your network automation. Now, if you want to follow along with me, I definitely encourage it. Go on up to GitHub and get all of the code and information and examples for this video course. github.com/cisco-devnet/netprog_basics is your place to get all of the information necessary. Every lab includes a README with the prerequisites on how to set up your workstation, along with details on how to access the infrastructure necessary to run this lab. Now let's dive directly into this content. We're going to cover 3 bullet points. What exactly is an API? Let's demystify those 3 letters. We'll realize they're not scary, and you're actually using many of them today already. And then we're going to end with a discussion about APIs that you should be familiar with as you start your journey into network programmability. So, what is an API? Well, let's go with a definition. An API is a way for 2 pieces of software to talk to each other. The letters stand for Application Programming Interface. Now, why did 2 pieces of software need to talk to each other? Well, if we think back, for a long time, us humans, we were the only users of systems. We would take action, we'd request data, we'd initiate processes through a user interface or a UI. And that software would display the results back to us through its user interface or UI. But today, humans are not the only users of systems and applications. Sometimes software is consuming other software. And in that case, this is where APIs come in. Now, if I build a software system, my software system, and it is interested in using your software, I will ask for that data or take action using its API, its Application Programming Interface. And then your software system can return its results via that same API so I can consume it. Now that means the API is the user interface for the software system. Or put another way, a little bit more specific, is the APIs are the set of requirements that explain how one application can talk to another application. It's a contract, it's an agreement, so that different applications can work together seamlessly. Now let's use an analogy. We can think about an API like an electrical outlet. What would it be like to power our hairdryer or toaster or any other device if we didn't have outlets in our houses? Well, we'd have open walls with wires just coming down through the next to the studs. We'd be responsible to strip those wires and manually splice them together from the walls to our appliances. We'd have to understand every wire in the wall, where they're coming from, where they're going to, what they support. Well, thankfully, we don't have to do that because the outlet provides a service that conforms to specifications that we understand as consumers. Every socket, at least here in the US, will deliver power at 120 volts, it's alternating current, and it operates at 60 hertz. Now, if you're in a different country, your sockets may be different, but it is well understood. So our appliances will work with our outlets. It sets the expectations on behalf of ourselves as consumers of the power utility that we want to consume. APIs do the same things. Now, if we look at it another way here, we've got APIs are like nuts and bolts and screw heads and bits as they go together. Now, we can have screws and hardware created by one company, one manufacturer, and bits created by another manufacturer. But because they align to the same specifications, we know that they'll work together. APIs provide that same capability in the software world because we agree and we understand how the APIs work, what they expect from us as consumers. We can allow all of our software pieces to work together seamlessly. And thankfully they can. They've opened up a whole army of new applications and services that we can consume as consumers. Let's look at a common one that uses them today, the Yelp application. Now, in the Yelp application, users are interested in locations of restaurants, ratings, details about those restaurants. Well, Yelp didn't want to build a whole mapping service and had send trucks out all over the road with cameras attached to them. They were just concerned with the actual restaurants, the information, getting the details to the users. So when Yelp needs the map data to identify which restaurants are closest to a user, they request that information from Google Maps. And Google Maps can return all of that data via the API in a standard fashion, which lets us have our smiley face because we can figure out which restaurant makes the most sense for us at the end of a long day. Now, because of this ability for APIs to enable applications and development teams to build such great services so quickly and easily by bringing together resources from across the web, APIs are often referred to as an engine of innovation. As an application, as a software developer, I can consume APIs from Google or Amazon or Cisco in building my application. And I don't have to do all of the hard work myself. I can take advantage of the services that are available via APIs. And so now we recognize APIs aren't scary, right? They're just ways for one application to consume another application. And in fact, you're already using them today. The CLI, the command line interface, the way that we interface with most of our networking kit today. Now, it was designed for humans, so it is more of a user interface than an API, but consider for a moment network management systems that interface using the CLI for automation. Expect scripts that you may have written yourself, like the example up on the slide here, where we write a script that is basically interfacing with the CLI, using the CLI as an API. And then Python modules like Paramiko and NetMiko, Napalm, all of these services in the network space are using the CLI like an API. But it's not the only API from the network that we're using today. What about SNMP, the Simple Network Management Protocol? Directly from the RFC, it was designed as a programmatic interface between management applications and devices. That makes it an API. It is widely used. I would almost guarantee that everybody watching this video is using SNMP today for monitoring. It has some limited use for configuration, and the primary consumer, as you would expect by something designed for one software to talk to another software, are those network management systems that are out there. So APIs are not new to us as network engineers. Now that said, there are new API frameworks that we may not be using today or may not be as familiar with today that will become more important as we journey into programmability and automation. Let's take a look at a few of those. Now we'll start out with one that's not necessarily something we're going to use day in and day out as a network automation and network engineer, but it's still important to recognize its place in the world. And that's SOAP, Simple Object Access Protocol. Now this is a mature API standard designed by Microsoft, and it's used to build web services. Now web services is another term that may be a little bit confusing if you just run into it, but it's really simply just software available over the internet. Web services is just something you can get to over the World Wide Web. Now SOAP will typically use HTTP, but it doesn't have to. It is, however, very dependent on XML. Now because of the way SOAP works, the interactions that the developers have to use, as well as its reliance on XML, it is sometimes considered complex and rigid, which has led to other API frameworks and standards to be designed. For example, REST, or Representational State Transfer. Now REST was specifically designed to provide a simpler web service platform than SOAP. And it is another use for that HTTP protocol. That same protocol we use to browse the web, search for information, is being used to provide the foundation for APIs for one software to talk to another piece of software. It's become very popular due to its performance, scale, reliability, and how easy it is to both develop a REST API as well as consume it as a developer. Now it is technically a framework more than a standard, and we have an entire 2 more lessons in this module dedicated to diving deeper into REST. Now HTTP as a foundation protocol for providing APIs doesn't stop with just SOAP and REST. We also have XML RPC and JSON RPC. Now these are both simple frameworks for communicating one application to another over the HTTP protocol. RPC stands for Remote Procedure Call, and that may be something you've seen or run across in your time as a network engineer talking with systems admins or Windows admins. And RPC is just another set of letters that we can demystify today. Remote Procedure Call just means I have one system requesting another system to execute some code and return the information. Very similar to an API just on its outset. Now, XML and JSON RPC will provide both XML and JSON data formats respectively as we go through. Now, next up in our APIs are two APIs specific for network engineers and network automation. And that first one is netconf. Netconf, or the Network Configuration Protocol, was designed as a replacement for SNMP. Netconf gives us a way to provide better standards, better communication to our network devices and agents that are out there. It was standardized in 2006, updated in 2011, and we're going to go very deep into the netconf protocol in a later session as we come through, along with Yang, the data modeling language that it's tightly coupled to. Now, as netconf became standardized and used, REST was growing in popularity as a basic API framework for different application systems. And so RESTconf was designed and standardized early in 2017 to provide a REST API-like interface to the network. It will support both XML and JSON, and we will give lots more focus on the RESTconf protocol in another later section, so stay tuned for that. Now, in summary, we've talked a lot about APIs. We defined what an API is, application programming interface, and recognized that they're not complex or scary. In fact, we're already using them. We went through a series of different APIs that will be important for us to understand and become familiar with as we build automation scripts and expose ourselves to network programmability. Now, call to action, right? We're just getting started in the Network Programmability Basics course. Be sure to follow along with me to completion to pick up all of the important skills to jumpstart your journey into network programmability. Join me up on DevNet for so much more than just this video course. We have learning labs, development sandboxes, code samples, API guides. And if you have specific questions, feel free to reach out to me directly. You can find me up on email or through Spark at hapresto@cisco.com. I'm active on Twitter at hfpreston and up on GitHub at hpreston. And be sure to follow Cisco DevNet on Twitter, Facebook, GitHub, Instagram, all the social medias for the latest from Cisco's developer program here at DevNet. Thanks so much for joining me for this lesson. Stay tuned for the next one where we'll dive even deeper into APIs with REST APIs. Thanks.